This video will be a quick overview of the three trigonometry functions that we're looking at and the inverses of those trig functions. So let's say we have a right triangle with side lengths 3, 4, and 5, and with angles 36.9 and 53.1. And let's use that 36.9 degree angle as our reference angle. So that's the angle that we're going to be writing our ratios in relation to. So the three trig functions that we are looking at are sine, cosine, and tangent. And what these functions do is they take an angle and they give you out a ratio of sides of a triangle that has that angle. And sine, cosine, and tangent are ratios of the sides of the triangle. So sine represents the ratio of the opposite side of our reference angle over the hypotenuse of the triangle. Cosine is the adjacent side to our reference angle divided by the hypotenuse. And tangent is the opposite side from the reference angle divided by the adjacent side to the reference angle. So with sine, cosine, and tangent functions, we input an angle and the function outputs a ratio of sides of a triangle that has that angle. So for example, if I'm looking at the sine function, we abbreviate that as SIN. If I input my reference angle, 36.9 degrees, the function is going to output the ratio of the opposite over the hypotenuse of a triangle that has that reference angle. So if I'm looking at this angle here, the side that's opposite across from it is going to be 4. So I'm going to label that as O. And the hypotenuse is the side that's always across from the right angle, and it's also always the longest side. So 5 is my hypotenuse. And then the only side that's left is the 3, and that's the adjacent side because it's touching the reference angle. It's right next to it. So again, if I'm inputting 36.9 into the sine function, what it's going to give me out is the ratio of the opposite side over the hypotenuse. So the opposite side is 4, and the hypotenuse is 5. So by looking at this triangle, I can tell that the sine of 36.9 degrees is the ratio 4/5. Now, if I didn't have a triangle with side lengths, I could also just put the expression sine 36.9 into my calculator, because any right triangle with a reference angle of 36.9 is going to have a sine ratio, an opposite over hypotenuse ratio of 4/5. So then let's talk about the inverse functions. With our regular sine, cosine, and tangent, we input an angle and we get out a ratio. With our inverse trigonometric functions, it's the other way around. We input a ratio and we get out the angle of the triangle that would have that ratio. So we denote our inverse functions with an exponent of -1. And again, what we input into our inverse functions is a ratio. Because this is inverse sine, I want to be inputting the ratio of an opposite side over a hypotenuse. So for this triangle, the opposite over the hypotenuse is 4/5. And then what the function will give me out is the reference angle of the triangle that has that sine ratio, which I can see here is 36.9 degrees. So again, with inverse trig, I'm inputting a ratio, and what I'm getting out is an angle. And so again, if I didn't have my triangle, if I didn't know what this angle was, I could just put inverse sine of 4/5 into my calculator, and it would give me out this angle of the triangle that has that sine ratio. So let's apply these trig functions and inverse trig functions to a couple problems. So here's a right triangle with a side of 12 and a side of 13, and this is our reference angle. I've marked it with the Greek letter theta, which you will often see used as a variable for angles. So I'm trying to solve for that missing angle theta. I need to decide, do I want to use my regular trig functions, sine, cosine, and tangent, or do I want to use one of my inverse trig functions, inverse sine, inverse cosine, and inverse tangent? Well, with my regular sine, cosine, and tangent, what I input is an angle, and what I get out is a ratio. Whereas with my inverse trig functions, what I put in is a ratio, and what I get out is an angle. Well, I don't know what this angle is, so I can't use my regular trig functions because I won't have anything to input. I won't have an angle to input. I don't know what that angle is. So instead, I need to use my inverse trig functions so that I can input a ratio and get out that angle that I'm trying to find. So now that I know I want to use one of these, I have to decide, do I want to use inverse sine, inverse cosine, or inverse tangent? And the way I'm going to decide is based on what sides I'm given in relation to my reference angle. So if this theta is my reference angle, the sides that I'm given are the adjacent side that's right next to it, and the hypotenuse that's across from the right angle. So which of my trig functions involves the adjacent side and the hypotenuse? That would be inverse cosine. I'll write as a reminder up here, we use the acronym SOHCAHTOA. To remember that sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, tangent is opposite over adjacent. So because I have the adjacent side and the hypotenuse, I want to use the cosine function, but I'm going to use the inverse cosine function so that I can input the ratio I have and get out the angle that I'm looking for. So I'm going to do inverse cosine of the adjacent over the hypotenuse, because cosine is adjacent over hypotenuse. So my adjacent is 12, and my hypotenuse is 13. So what this expression means, inverse cosine of 12 over 13, this expression, if I were to translate it into words, means the angle of a triangle that has a cosine ratio of 12 over 13. That's what this whole expression means. And so I can actually just put that in my calculator and get out what that angle is. So if you're using this type of calculator, you would press second, and then press the sine button, and then press the cosine button, and that's going to give you that inverse cosine function. And then I'm going to type in my cosine ratio, 12 over 13, and what the calculator is going to give me is the angle of the triangle that has that cosine ratio. So I'm going to round that to about 22.62. So in this problem, I used my inverse cosine ratio, and I plugged in the ratio 12 over 13 to find out that the angle of a triangle that has a cosine ratio of 12 over 13 is 22.62. Now let's do an example where we're trying to find a missing side instead of a missing angle. So here I've got a right triangle with a side of 11, a side labeled x, and a reference angle of 37 degrees. And I want to find that missing side x. So I need to decide, am I going to use one of my sine, cosine, tangent functions, or am I going to use one of the inverse functions? Well, for the regular sine, cosine, tangent, what I input is an angle, and what I get out is a ratio of sides. Whereas for the inverse functions, I input a ratio and I get out an angle. Well, I can't input a ratio in this situation because I don't know what this side length is. I don't know what the ratio of two sides is for this triangle because I only know one of the side lengths. So I'm not going to use one of my inverse functions. I'm going to use one of my regular functions because with those I input an angle, and I know an angle in this triangle, so I can input that into one of my trig functions. So for this triangle, I have the side that is adjacent to the 37-degree angle, and although I don't know what it is yet, I'm trying to find the hypotenuse. So just like last time, the trig function that involves the adjacent and hypotenuse sides is cosine. So I'm going to start with cosine, and what I'm going to plug in here is an angle. So I'm going to use my reference angle 37 degrees. So if I were to translate this expression into words, cosine 37 degrees, I would say this is the ratio of the adjacent side over the hypotenuse of a right triangle with a 37-degree angle. That's what this expression is representing. And I know that that ratio is going to be equal to the adjacent side 11 divided by the hypotenuse, which we're calling x, which we're trying to solve for. So now I just need to solve for x. So since 11 is being divided by x, I can undo that by multiplying both sides by x. I'm going to write it as x over 1 just to make it a little more clear what's happening here. But we're multiplying both sides by x, because then the x that we're multiplying by is going to cancel out with the x that we were dividing the 11 by, and we're just left with 11 on the right side. And on the left side, we have x times cosine of 37 degrees. Now remember that cosine of 37 is just a number, right? It's just a ratio, it's a number. So if x is being multiplied by that number and I want to get x alone, I just need to divide both sides by that number. So I'm going to divide the left side by cosine of 37, and I'm going to divide the right side by cosine of 37. On the left side, those will cancel out in the numerator and denominator, and so I'm left with x is equal to 11 divided by cosine of 37. And now I can actually put this whole expression into my calculator to get a decimal approximation for it. So I'm going to do 11 divided by cosine of 37. You want to make sure that your calculator is in degree mode. So if you're using a physical calculator, it should say degree right here and not radians. And then it's telling me that that side length is equal to about 13.77. So we used our cosine function here to figure out that if we have a right triangle with a reference angle of 37 degrees and the adjacent side is 11, then the hypotenuse has to be 13.77. Let's do one more example. Here's a right triangle with a reference angle of 32 degrees, a side of 13, and a side x that I want to find. Again, I can't input a ratio because I only know one side, but I can input an angle because I do have an angle. So I input angles into my regular sine, cosine, tangent. The sides that I'm working with here are the side adjacent to the reference angle and the side opposite from the reference angle. So the trig function that deals with opposite and adjacent is tangent. So I'm going to set up that tangent of Remember, you're inputting an angle, so I'm inputting this 32 degrees is equal to, and tangent is a ratio. It's the opposite side, which we're calling x, over the adjacent side, which is 13. So now this one is a bit easier to solve. Since x is being divided by 13, I'm going to undo that by multiplying both sides by 13. I'm going to write it as 13 over 1, so that again you can see what's happening a little more easily. The 13 that we're multiplying by is canceling out with the 13 that we were dividing by. So I'm just left with x on the right side, and on the left side I have 13 times tangent of 32 degrees. Remember, tangent of 32 is just a ratio, it's just a number. So I can put this whole expression in my calculator and get an approximation for x. So I'm gonna type in 13. You could use a multiplication symbol here if you want, but you don't need to. Times tangent of 32. Again, make sure your calculator is in degree mode. And that is roughly equal to 8.12. So I used my tangent function here to find out if I have a right triangle with a reference angle of 32 degrees and an adjacent side of 13, then the opposite side has to be equal to 8.12. So to close, I want to remind you and summarize that for sine, cosine, and tangent, we input an angle, and what we get out is a ratio. Right, so for sine, we would get out the ratio of the opposite over the hypotenuse. If we input an angle into cosine, we'll get the adjacent over the hypotenuse. If we input an angle into tangent, we'll get the opposite over the adjacent. So again, we're inputting an angle, and we're getting out a ratio. Whereas for our inverse functions, we're inputting a ratio, and what we're getting out is an angle. So for sine, we would input a ratio of an opposite side over a hypotenuse. For cosine, we would input a ratio of an adjacent side over a hypotenuse, and we would get out the angle of the triangle that has that ratio. For tangent, we would input the ratio of an opposite side over an adjacent side, and we would get out the angle of the triangle that has that tangent ratio. So for our inverse functions, we're inputting a ratio, and we're getting out an angle of a triangle that has that ratio.